Hey all, we are on Calculus Lesson 2 of Unit 1. This is 1.3 because we had skipped Section 1.1. This should be the first handout you got, and in this handout you're looking at the 6 parent functions, and we're going to look at their domain range and where they're increasing, they're decreasing, kind of a continuation of last lesson, right? So this should be pretty straightforward to you if you need some help getting started. For these, you can choose whatever coordinates you want. So it can do like -3 is -3, and right, 0 is 0, and 1 is 1, for example, right? And so for this one, you're going to get a line going through these points, the domain. So we can say it's true for all numbers, right? So one thing we can use is this as R, which means all real numbers. Okay, so if it's all real numbers, you can use this R. Okay, it's like that. The x-intercept of 0, the y-intercept of 0, and it's increasing from -infinity to infinity. It's never decreasing. Okay. Here we have the absolute value. This is how to do it in your calculator. So math num abs will get you to the to this function. So we're going to see a sort of a V form here, and you might have like -5 and 5, 0, 0, and there's 3, 3, right? Whatever you want here. This is not. This is optional, right? Again, the domain is all real numbers, but the range is y must be greater than or equal to 0, right? Or we could say, y is 0 to infinity, right? Either of those is fine. X-intercept 0, y-intercept 0. It's increasing from 0 to infinity, but it's decreasing from -infinity to 0. Okay, we've got a quadratic here. X squared. We're familiar with these where we have a parabola, right? So you might have like -3 is 9, 0 is 0, and 1 is 1, right? Whatever works for you. The domain, again, that's all real numbers. All real numbers for the for the range. No, the range is from 0, so it's y greater than or equal to 0, same as above, y 0 to infinity. Okay. Again, 0 and 0 here, and then it's increasing, same as above, 0 to infinity, and decreasing from -infinity to 0. Right. From -infinity to 0, it's going down. From 0 to infinity, it's going up. Okay. Next side here, we've got a cubed function, cubic. Okay, so you would plug in like a -3, and you get -27. A 0 would get you 0. A 2 would get you 8, right? And you get a function that looks something like this. It doesn't have to be perfect, something like that. Okay. The domain is all real numbers, the range is all real numbers, the x-intercept of 0, the y-intercept of 0, and it's always increasing from -infinity to infinity, right? It's always going up. Yeah, right, from left to right. It's never decreasing. Okay. Next, with a root, and we might plug in 0 and you get 0, and a 4 you get 2, and a 9 you get 3, and graphing it you'll get this function, something like this. This is not to scale, but something close to that. And the domain, well, it can't be negative, right? So the domain for x greater than 0, greater than or equal to 0, or x could be from 0 to infinity. Same with the range, right? y has to be greater than or equal to 0, or it's got to go from 0 to infinity. Same thing. Okay, x intercept 0, and 0 is always increasing from 0 to infinity, never decreasing. Okay, last one, 1 over x. This is called the reciprocal. Okay, so plug in a 1, you get 1. Negative 3, you get negative 1/3. 4, you get a 4th. And if you think about this one, as you divide by smaller and smaller numbers, it gets super, 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 super big. Right? As you divide by bigger numbers, it gets smaller. And it mirrors that on the negative side. But what happens here in the middle, we have what? We have a vertical asymptote because you cannot divide by 0. So we can say x is all real numbers and x cannot equal 0, and y is all real numbers but y cannot equal 0. Okay, x-intercept, there is none. There is no y-intercept. It's never increasing. It's always decreasing. Okay. So the next 4, these you can use your graphing calculator for, so you can do that. We have ln x, which should look something like this. We have e to the x, which is going to look like this. We have sine x, which will start at 0 and something like this. Depends on your scale, but it should be something like this. The important thing is like the starting at 0, and then the cosine, which starts at 1. Right, this might not be to scale, right? But that's the important thing. The cosine, this is 1 right here, and this is 0, 0. Okay. All right, so hopefully you've got through that okay. Next would be handout 2, which is this: how much do I pay for 4G data? So hopefully if you've tried this at this point, and if you need help, you're watching the video. So what factors play a role? So okay, cell phone plans used to charge by number of minutes and text sent. Now most phones have unlimited, but offer a different amount of data, different costs. Today we'll look at some pricing structure for phone plans. What factors play a role in choosing a cell phone service provider and picking a plan? So price, how much data you need, right? Where you get service, international plan, if that's relevant, right? Anything like that, it's open-ended answer. 2, Metro by T-Mobile offers unlimited text and talk with 2 gigs of data for $30. If you exceed 2 gig, you pay a rate of $10 for each additional gig. What would the monthly phone bill for somebody who's 1.7? Well, that would be $30, right? Because you didn't exceed the data limit. It's just a flat fee of $30. If you use 3.5, well, you are going to pay that $30 for the first 2 gigs, right? That's 30, and then you're going to have to pay an extra 10 for the 1.5 that you went over. So in total, you would be paying 45 for this one, right? So what does this look like? Well, if we think about the monthly cost for the first 2 gigabytes of data, you're just paying that flat fee of $30. But as soon as after this, you then start paying an extra $10 per gigabyte. So this is 40. So at 3, you're at 40. At 4, you're at 50, and so on. This is like the extra $10 per gig. And we're going to write a rule for this. So this is saying that when if x is less than 2, you're going to pay $30, right? But if x is greater than 2, you are going to pay, well, we're trying to find a function here. We can see this is going to be c equals 10. If we think about this like this is a function here, we can write this as c equals 10 plus 10x. Okay, that makes sense. So if it's below 2, we follow a certain rule, and if it's above 2, we're going to follow a different rule. Okay, and this is introducing what's called a piecewise function, and we're going to get into that in the notes right now. Okay, so you should be on handout 3. This is the one before the delta. This is what's called a piecewise function. So if you think about this handout, this idea that for different periods we have different functions. That's what piecewise functions are all about. We have different functions, either functions here on the left, or different rules you can think about for different domains. These are different areas. So, for example, this one, it's saying that for everywhere less than 1, we're going to follow the function x minus 4. So looking at this, if I'm less than 1, well, it's actually easy. Let's start with the x greater than or equal to 4. So this will be 1, 2, 3, 4. It's just 1. So everywhere x is greater than 4, we're just 1. This is just 1, right? For x is greater than or equal to 4. But for where x is less than 1, so over here, we're going to follow the rule x minus 4. So at 1, I should be at 1, 2, 3, 4 here. And that is going to look like this. Okay. So this is what we end up with. So there, it's like a different function for different parts of the graph, different x values, basically. And that's how it's written. Okay. So evaluating this, sometimes you get problems like, well, what is f of 5? Well, if you want to find f of 5 algebraically, you're just going to go to the 1. Where is 5? Is 5 less than 1? No. Is 5 greater than 4? Yes. So what's f of 5? F of 5 is 1. Same thing here. F of 5 is 1. If you wanted to find f of negative 1, well, is negative 1 less than 1? Yes. So you can put it in this. Negative 1 minus 4 is negative 5. You could also find it on the graph here at negative 1 and 5. But if you had something like f of 2, is 2 less than 1? No. Is 2 greater than 4? No. This would be undefined. Okay, because there is no f of 2. Evaluating algebraically, I just kind of went over that. It's the idea of you check function to see which domain it falls in, and then to use that rule, right? So what I mean by that is what I was just talking about. Like if you have 5, where does 5 fall into? Well, 5 is greater than 4, so I use this rule. If you do negative 1, where does negative fall into? Less than 1, use that rule. Of 2 doesn't fall into either of them, undefined. And that's it. Thank you guys. See you next week.